Hello, gentlemen. Today we're going to get into one of the fun pieces of calculus, and that is finding the area under curves. In my opinion, calculus is all about three things. It's one, reading graphs. You've been doing that since grade school. Two, finding slopes, and that's taking derivatives. And third is actually finding areas, which has to do with antiderivatives and the summations. So basically, today's WebAssign has four questions that are very similar to the one that I have right here. And so I'm going to walk you through it. We're actually going to do this problem twice. And I might consider, you might even want to watch this video a second time. So this one says, consider the function f of x equals x squared plus x minus 4. So that would be a parabola shape, and I've already gone out on Desmos, and that's what this graph here is showing that function. It says estimate the area between the graph of f of x, well that's the red shape we're looking at here, and the x-axis. Okay, I know where the x-axis is. It's right across here. And between x equals 2, okay, so here's x equals 2, and x equals 4, so that's right here. So basically what they're asking us to do is to find the area that is between x equals 2 and x equals 4, the x-axis, and the curve. So what they want us to find is all of this area inside here. Now, if that was a square or a rectangle, that would be a piece of cake. I could use some formulas, length times width, or if it was a triangle, 1/2 base times height. But I can't do any of that because this is not a square shape. That function is a parabola. It's got a curve up here. So how in the world am I going to find this? Well, it says find the area using 4 rectangles and the right endpoints. So we're going to do this problem twice. And the second time, we're not going to use right endpoints. We're going to use left endpoints. So I'm going to kind of clean up my drawing here a little bit so we can, again, see what we're doing. All right, so it says find the area using 4 rectangles. All right, well, let's think for a second. If I'm going to draw 4 rectangles in here, not sure what happened there. If I'm going to find the area using 4 rectangles between x equals 2 and x equals 4, then if I'm going to do 4 rectangles, they're going to have widths basically like this. One of the rectangles is going to be this wide. One of the rectangles is going to look like this, and one of the rectangles is going to look like this, and one of the rectangles is going to look like this. So basically, each rectangle is going to have a base that is a 1/2 inch wide. If they had asked me to break this into 8 rectangles, well, that would have changed the base. If they had asked me to break it into 2 rectangles, well, then each would have had a base of 1. Okay, so I'm going to have 4 rectangles that have bases of 1/2. They also asked me to use the right endpoints. Now, what that means, guys, this is the tricky part, is this first rectangle here kind of looks like this, but on the left side, my rectangle has a height of 2, and on the right side here, my rectangle has a height of 4.75, and this one says use rectangles with the right endpoints. So this box here, I'm going to use the right endpoint, and that's going to be my rectangle. For the next box here, here's the left side, here's the right side. The right side comes all the way up to here. This guy is going to have a height like that. This rectangle over here is going to have a height like this. And this height, this rectangle, is going to have a height like that. Okay, so that's finding the area between x equals 2 and x equals 4 with 4 rectangles and using the right endpoints. Now, in a moment, in a little bit here, we're going to repeat this process but we're going to use left endpoints. So if I do this again and I'm using left endpoints, what I'm actually going to do is I'm still going to have 4 rectangles. But if they're asking me to use the left endpoints, that means the first box is going to look like this. Notice I didn't use the height of the right side over here. I used the height of the left side. The next box is going to look like this. Again, notice that I'm using the left side, not the right side. This next guy is going to look like that. And this last guy over here, it's hard for me to draw straight, it's going to look something like that. Now, what you'll notice is neither of these are really going to give me the correct area. This guy here is going to be missing area. And my original one up here is actually going to be too large because you'll notice I've got these areas in here where I'm grabbing too much area. So the true answer is going to be somewhere between these two answers. And when we actually get a little further, we'll figure out how to do that correctly too. All right, so let's continue here. I'm trying to find the area between the f of x and the x-axis between 2 and 4 using 4 rectangles and the right endpoints. Well, I just need to find the area of these 4 rectangles and sum them up. So let's start with rectangle number 1 here. Rectangle number 1 has a base of 1/2, and he's got a height of 4.75. And so rectangle number 1 has an area of 2.375. Now you might be asking yourself, well, where did he get all these points? Well, I realized again that the places that interest me were at x equals 2, x equals 2.5, 3, 3.5, and 4. And I just came up here and I used the function. That's where I got these values. If you put in 2, f of 2 comes out to equal 2. And that's what that spot is right there. And I just found f of 2.5, f of 3, f of 3.5 using this original function up here. So this first rectangle right here has an area of 2.375. The next guy right here, I'll call him number 2, he has a base of 1/2, and he's got a height of, it looks like 8. And so he's got an area of 4. The third rectangle over there has a base of 1/2 again. He also has got a base of 1/2. And he's got a height of 11.75. So his area is actually going to be, oh boy, can I do my math here? 5.875. Yeah, I think I did that right. And rectangle number 4 is going to have a base of 1/2 and a height of 16. So he's got an area of 8. When I add up all these 4 areas, and I'm just going to pull out my calculator real quick to make sure I'm doing this math real good here. 2.375 plus 4 plus 5.875 plus 8 comes out to be 20.25. If I estimate the area that's between 2 and 4 and bound by the x-axis in this graph, I come up with an estimate of 20.25 if I use the right endpoints. Now again, the real area, guys, is less than 20.25 because when I look at this right here, I mean, I got all of this area that I measured. That's extra area. That's not under there. So this is too large of an estimate, but it's an estimate of the area under there. Let's try to do this again, but this time we're going to use the left endpoints. So again, we're still breaking it into 4 rectangles. Each rectangle still has a base of 1/2, but the heights are different because I'm using the left side of my rectangles, not the right side. So this first rectangle here is going to have an area. It's got a base of 1/2 and a height of 2. That guy's got an area of 1. The next guy has a base of 1/2 as well, and he's got a height of 4.75. So he's got an area of 2.375. Box number 3 here has a base of 1/2 and a height of 8. So he's got an area of 4. And triangle number 4 here has a base of 1/2 and a height of 11.75. And so that comes out to be 5.875. If I add up these 4 box areas together, and again, I'm using my calculator here so that I don't make any mistakes. Thank you, Bob, for sending me your handlebar grip. We get an area of 13.25. Now, this is actually too small of an area. Why? Because we didn't capture all of this area in here. We missed all of that area. Again, this is an estimate, okay? This estimate is a little low when we pick the left side. Up here, when we calculated the same area, we came out with 20.25. And again, this one was a little high. The real answer is somewhere between those two answers. And we'll figure out how to do the exact answer later on. The key is going to be, we're not going to break this into 2 boxes or 4 boxes or 10 boxes. If we start breaking the area under 100 boxes, these areas would become much smaller. And of course, what we're going to end up doing in the long run is we're going to break it up into an infinite number of boxes, and each one is going to have a width that is practically 0. And when we start breaking it up to an infinite number of boxes, all of this error will disappear. Gentlemen, the WebAssign has 4 questions out there for you to work on. This is a little bit confusing, so please remember I am out on Teams and more than happy to help you. Stop on by and I'll work with you. You might even find that you want to watch the video a second time to just absorb it all in. I hope this helps, and I will talk to you later.